Welcome back to our one challenge to recap all section. So in this video right now, we will have a look into printing out more complex objects. And we will also have a look into inserting more complex Smiley code into an existing application. So I will show you an approach how we can easily do this, and therefore I would suggest let's simply dive into this one. So let's open my terminal, and we're still working on apps and one challenge to recap all. So this is our AES crypto challenge. We are opening it with JDX-GUI and have once again a quick look into this one. So let's see, within COM app hacking AES, and here we have this AES crypto class. Okay, in the last video we have seen how we can deal with unknown Smiley syntax, and this was pretty amazing because we have never ever reverse engineered try and catch blocks within Smiley. But we could immediately understand what's going on over here. We could figure out how they work, and therefore we are able to manipulate, delete, or interact with them. And this is all that matters. We understand the functionality of them, and yeah, we can play around with them. In this video, we will have a look into printing out more complex objects. For example, this byte array over here. Byte array doesn't sound that complex, but we will have a look. Then we are having an AES crypto function. So we have a key in initialization vector, how to deal with these objects. We want to get them on our terminal. We want to have them printed out, that we can work, that we can encrypt and decrypt our text. How can we do this? Our key is simply just an object from secret key. So can we write system out print line secret key? I guess not, and this is not possible. So therefore we will learn how to do this. And last but not least, we will also have a look into inserting more complex Smiley code into an existing application. Let's say we want to insert a Smiley code that works with certain objects, certain encoding methods, and prints out some stuff and performs some other actions. How can we achieve this without writing everything in line in Smiley there? So therefore I would suggest let's start with this one. And we start with the secret key. How can we print out the secret key? This secret key is from the type JavaX crypto secret key. So this is a generic class, which means we have a really good documentation on this one. And those classes often have setter and getter methods to work with them, because this AES encryption method has to work with this secret key. At a certain point, it needs to get out these single bytes out of this key. And therefore, a good starting point would be having a look into the official documentation. Maybe we find some additional methods, which are not used over here, to get out this key in a certain format. If we cannot find anything for this one, maybe we want to have a look into the key generator, because this is generating a key. Maybe we can do something with this one over here. All right, and therefore let's go. We simply take this JavaX crypto secret key and append Android, because otherwise we might get some Java references, and these could differ from our Android developer documentation. So let's see, here we have the secret key, Android developers. Okay, this is a public interface, all right. And let's see, here we have those methods, and these are inherited. Let's click on this one. Okay, those methods come from JavaX security key. Let's see, we've got a method getAlgorithm, returns the standard algorithm name for this key. It doesn't sound that interesting for us. GetEncoded returns the key. Oh, this sounds good. Returns the key in its primary encoding format, or null if this key does not support encoding. So not sure what this one means, but it returns the key, and this is all that matters. The return type is here. It's a byte array. Perfect. We already have to deal with a byte array because we want to print out this plain text. This means we have now a method that gets out this key in a byte array, and this method is named getEncoded. So what we could do right now is the following. We could add between those two lines now our key.getEncoded method. So we perfectly know how to do this in Smiley. We know it's something invoke. I guess it's not virtual if you're dealing with inherited methods, so we would have to look this up. But then we simply got our class reference, which is this one over here. We provide our error. We call the method getEncoded. Let's see, do we have parameters in there? I guess not. No parameters. Perfect. So we could easily do this. But now I would like to show you an approach which is a little bit easier and also which handles more complex syntax a little bit better. And this approach is definitely no rocket science. So what we're going to do right now is the following. Let me draw this on the graphic tablet real quick. Okay, so what we do is the following. We take this code out of this application. For example, this line. We want to call the line key.getEncoded. Key, that's a small key, get encoded. No parameters. And we are taking this line into our own application. So we will create an own app with this line of code, because then we can also adjust the other Java code to make this working. And we could modify this code in any way. For example, we could print out if this even works. We could use system.out print line, and then we use this part over here. And if this works, then we can compile this into an application. So we can build this APK file. So here we have this APK. This is our APK. And then we could simply take our APK tool to get out the Smali files out of this one. By having those Smali files, we already have our code in a proper way, how it works in Smali. And then we can take this code out of the Smali file, only the necessary part, and we can pull it in between those two lines, directly here. And by doing this, we can play around in the Java world over here. If everything works, we can experiment around with this one. We can insert more additional code. And then, yeah, we slice out this little piece and pull it in here. Absolutely no rocket science. And you might ask if it's that easy and we can simply copy paste this code into this application, why haven't we done this earlier? The reason for this is we have to consider a few things. And these things can be only considered if we fully understand the Smali part. Let me show you what I mean. So here we have our application. This is the original application. This is this part right now. Okay, now we are inserting our Smali part. Let's say in between here. We are inserting a little piece of Smali. This is between those two lines, for example. Now we have to be a little bit more careful because let's say we are overwriting certain registers. Let's say we are using V2 and V3 in this part. But these registers might have been already set up over here. So here we have the original code, and this is now, we have to consider this as a single part. So in this part, we have now a register V1 and V2. Let's say V2 is a very important object. For example, this, let's say it's this keygen object. This key generator might be used in this part over here, somewhere in between here. And now, if we do not understand Smali, we will override this key generator object here with something like, for example, system.out. System.out. And then at this point, when it references to the key generator object, over here, for example, we are not having a key generator object anymore. This is now a system.out object and it will crash. It doesn't have to crash, so it could also work quite a while until something happens. So therefore, what we need to do is we need to insert our code in between those two blocks. So this is the first block, this is the third block, and in between, this is our block. We are block number 2. We need to insert it and we need to make a transition. So in case if you want to overwrite registers, for example, this V2, we have to restore this V2 register afterwards. So here we have to assign it back again to the key generator. Or what we of course can also do is we could increase those registers. So let's say we increase the number of registers to a number, for example, let's see, 8. So let's say before we have 5 registers, but now we are using .locals 8. So .locals 5, and we are increasing this to 8. This means we have now additional registers available. For example, we have now, that's pretty hard. Let's do this from the beginning. V0, V1, V2, V3, V4. So these are our 5 registers, our original one. Now we get additional 3, which is V5, V6, V7, because we start from 0, the counting. This means we do not have to overwrite a certain register like this one. We could simply use a new one we have created. For example, V5. All right? Perfect. So therefore, we will now write this application and we will figure out if everything works. So back to this one over here. If we get finally our key, this one here in a readable format, for example, as single bytes, as a byte array, or as some kind of other format, then we can take the whole Smiley code we have created over here and we can apply this patch over here. So this is the approach. We write our application, we test everything in the Java world, and if it works there, we compile this app, and then we make the transition into the original application. So we are doing this part afterwards. Okay, let's do this. Okay, I'm not sure if you have already written an application in this course over here, but it's not that hard because this application will be completely set up and all we have to do is we have to insert some line of Smiley. We can already understand the whole concept of this one, what an activity is, what the onCreate method does, all the stuff, and therefore you do not have to be afraid about this app development. It's not like that we are writing a complex, multifunctional, highly layouted application. We are just inserting some line of code. So therefore, let's go. We go into Android Studio bin and we start the studio.sh script. Okay, if you do not see anything, then simply just click on here because the view has not been loaded right now. So if you do not have this view, if Android Studio is already starting with a project, all you have to do is go onto File and then close Project, and then you are also here back again. Then we can click Create New Project. And then we choose Empty Activity because we do want to have it as simple as possible. So we do not want to have fancy button navigation or floating buttons and things like this. Just an empty activity. Okay. Then we give it a name, and this is our Smiley supporter. So then a package name will be automatically being granted. This is now com app hacking Smiley supporter. This is the location. You can choose a directory where you want to have it, but I like to keep it in the home Android Studio projects folder. Here we have language, and I like to stay to Java. Now this one is important. In case if you run it on your real smartphone and your real smartphone is version 7, then you need to go back to version 7. So this is the minimum requirement SDK. So we can go back with this application to version 7 if we select it over here. I will do this right now because it's simply just an app and yeah, it doesn't have to have these many features. So therefore the backwards compatibility shouldn't be that hard right now. Okay, we click finish. And that's it. Now the Gradle build will be started and this might take a while. But this Gradle build will set up our app completely, so all we have to do is simply run it afterwards and it will work. And therefore I will see you in a moment until this process has been finished. You can observe this at the bottom over here. Okay, the Gradle build has been finished and now what we want to do is we do not want to copy paste this whole code. Why? Because this is an interpretation of the original code and we cannot simply take the whole code and overwrite the original Smiley file. This might sometimes work, but most of the time, example regarding to real-world applications, this definitely doesn't, because we cannot compile most of this code. Here we only have generic classes, which is pretty nice. This might work, but on a real-world application, you would have so many dependencies that are unable to be resolved that you cannot fix this code right now. Otherwise, you could simply re-implement this whole application. And yeah, this is unfortunately not possible. Okay, beside this, even if this would work right now, I'm not a big fan of patching something where I'm not fully in control of. So if we only take some single lines out of this, then we can understand them and we can insert them in the original application where we want them to have. In case if we are simply just copy pasting everything blindly, then we might encounter some errors. So therefore, let's do it this way. Okay, we want to have this one. We want to have a secret key object. Let's take this line and simply insert it over here. Now we need to import it, and it already says, oh, this might be JavaX crypto secret key. If you hit Option Enter or Alt Enter, then this will be automatically be imported. You can see this over here, and we're good to go. Now we've got this keygen, and we haven't initialized this keygen yet. This might be also the error. Yes, we have to create a local variable, but we could also use this from the original code. So back to the original code. Here we have this keygen, and it's also using this method before. So let's simply copy both of them. All right, once again, we have to import these files. And here we have now an error. Let's see. This method can cause an exception, and therefore we have to surround it with try and catch. We simply have to click it here, and then it's done. So now we have transferred this code into our own application. And we could verify if this works by simply saving it and then building this application. So we click on Build APK. Okay, and here we have it now. So build APK successful. Here we have now this application. We are not going to install it right now. Oh, yes, let's do this. So let's connect to our smartphone. Do we have already a connection? Yes, okay. Which means we can simply use it in our Android Studio. So here we can see it's now switching because we have killed the ADB server. Android Studio is using the ADB server also, so therefore we stay here. Let's simply install it here. And yeah, please wait with the screen copy until this installation process has been finished. Okay. So now we can get the screen. And here we have now our application. Smiley supporter, hello world. Okay. Looks perfect. Okay, next we want to call the method getEncoded because this is the method that returns our secret key in form of a byte array. So key getEncoded. Here we have it. And we have also seen this method is returning back a byte array. If we build this application in this way, then one instruction will be missing. So if you're doing it in this way, the object will not be moved into a register. So this result object, the byte array finally, in our Smiley part right now. And we can force this instruction by simply assigning it to a variable. So therefore, let's simply create an own array and byte array. Let's call this my array. Oops, and let's assign it over here. By having it in this way, we can be 100% sure that we are having this getEncoded method, and afterwards we have the instruction move result into register v0, for example. Okay? All right, so now let's see if this approach even would work. So can we print out a byte array in this way? My array. Okay, so far so good. We do not get errors. Let's see, we have saved this file and we simply click run. So you can see this prototyping, it's pretty easy and it just takes a few seconds. Okay, so here we have it. And yeah, we do not have to observe this application anymore. We simply have to take a look into the ADB logcat output, and you can find this over here. So here's the logcat output, and now we can search for system.out. And this looks a little bit strange, right? So we've got this byte array, we know this part from Smiley, and then we've got an address. So this is only the reference to this byte array. So the system out approach doesn't work on a byte array. What we could do, of course, is the following. We could iterate over this byte array with a for loop. But there's a better option. The better option is already included in the original application, because the original application is printing out the encrypted text, which is also consisting of bytes, in a visual format. Do you still remember how? No? No problem. Let's have a look. So let's open a new terminal. Let's get the screen. Here we have this application. And here we have our AES application. And now, yes, you might remember. Read me if you can. Then we've got this encoding and the equal sign at the end, base64. Base64 is a really nice encoding to get those bytes into visual ASCII output. So why not simply take this byte array and encode it with the base64 encode method. Let's have a look into the original application, how they have resolved this issue. So let's do this. Okay, main activity. And here we have it. So this is from Android util base64. We've got encode to string. We have already figured out this takes two parameters. The first one is a byte array, pretty good. And the second one are just those flags, which is being initialized with 0 over here. Okay, let's take this method. So let's take this over here. We can delete this right now. And let's do it in this way. Base64 encode to string. If we hit Alt Enter, then this one will be inserted over here and we can use it. So now we are using my array. All right. And we are missing one parameter, so we are also choosing the value 0. Okay. We could now save this into another text, or we could do it in this way. I guess this is now the better approach. So let's see if this works. We click on Run. And there we have it. Nice. So this one over here, this is our base64 encoded text. This is our secret key in the base64 format. So we can simply use base64 to encode the string, and then we can use our system out approach to print it out. Pretty ridiculous nice, right? Absolutely. And therefore I would suggest, let's try decoding it first. Base64-D. All right. XXD-P. There we have it. So this is the way how to get out those bytes of the secret key. And now we have to verify this. We are not doing this right now. You could do this on your own if these keys or these bytes are really working right now. If you're not sure how to do this, I have provided you an AES bonus video where you learn all the stuff, because this would make this video unnecessarily long, and I've got a feeling that it will already become long. Okay, so now we know how to print it out. The only thing I like to change maybe over here is this can get messy in the Smiley part. So I guess a better approach would be simply split this up. Let's create also a string variable. Right, string, and use it over here. Okay, we have to swap them. Now we're good to go. So this means those two can be ignored. These are not relevant in the Smiley part right now. These are just necessary to create complete Smiley syntax. Okay. This one is the old original code. Old original code. This one is still the old original code, and this is our code. Our code we want to insert. And then we need to print it out over here. Yes. So this is our application right now we want to have. So we want to have these Smiley lines regarding to these Java code lines. And then we are taking them and simply inserting it over here. Not here, but here, between secret key and the ciphertext. Okay, let's do this. So we go on to build, build bundle, build APK. Here we have now the APK. We click locate. There we have it. We rename this to, what was the name? Smiley supporter. Okay. And then we are using APK tool D on the Smiley supporter. And then we are using Visual Studio Code on this whole directory. Okay, I trust the author because I'm the author and I'm absolutely trustworthy. So let's see. Smiley classes 2, com, app hacking, main activity. This is where we have inserted our code. Now we need to separate this. So we need to make sure, or we need to figure out what's the old code, this one over here, and what's our code we need to insert. The old code is this one, secret key, generate key. This is the last line. We can find this in the original application over here. we want to insert our code afterwards. So we are reusing this line, and then we want to have the instruction after this one. So we are searching for generate key. Let's search, and here we have it. Yes, this is the result will be moved into v1, and then our code starts. So this is the beginning of our code. Beginning of our code. Okay, let's maybe check this out. Is this line number 35 matching with the Android Studio? And it does. Okay, this is pretty awesome. I wasn't sure if JDX, the APK tool is matching this one over here, but it's perfect. We can identify our line number directly. Yes, do not rely only on line numbers, also verify this code. So we've got my array get encoded. Let's see. Yes, we've got key. This is our secret key. This is v1, and we've got invoke interface. Oh, it's not invoke virtual, it's invoke interface. We've got invoke interface on our method get encoded. So this one here is secret key dot get encoded, and it returns back a byte array, which will be stored into v2. If we do not assign this variable in this way, so let's say we are just calling it, then, and then this line will be missing. So therefore, it's good to assign this stuff. I mean, we could easily add this by ourselves, but yeah, it's good to have complete Smali code in here. All right. So this means all we have to do is, let's see, we have to take these 3 lines and we need to insert it into the original application. Maybe we can, let's see, maybe we can make this a little bit more clean. I mean, we do not need labels in our new original application, so therefore we can get rid of these labels, I guess. So let's see. Okay, and then also this one over here. Yes, these are all the lines. This is the beginning of our code. And this one over here, this is the end of our code. Okay. Now let's open them side by side. We put this on the right. I guess if we click the Explorer, or if we click on this one, yes, this will be closed. And now we have to take a look into the AES Smali file, into the original AES application. This one over here. Okay, CD apps, one challenge to recap all. Let's open the whole AES directory. And let's put this on the left one. Okay, we are within the AES Crypto Smali, that's correct. So we had it open from the last time, okay. And now we have to find, maybe let's focus first on the original application. And so we have to find this generate key line in this application. And I guess I can already spot it, line 21. Let's see, let's put now the original code next to it, line 21. So this is now the code, and here we have the JDX output. It's line 21. Yes, this is correct. Okay, this is our generate key. And afterwards we have to insert our own code. End of our own code. Okay. So far so good? Perfect. Then we can minimize this one, and then we can go into the right side. So here we have this. I guess it's a little bit better if we do some more hashtags, then it's easier to recognize. Okay, so now we copy paste this in between those two. Okay, and now we need to make sure that the transition is working properly, because we have used maybe different registers here than here. So the transition from the original code into our code back to the original code. Therefore, we can now close this part. Our code is not relevant anymore. So this can be closed. And now this is something I definitely want to have on the graphic tablet. Let's see. Yes, here we can see enough. So we take this on the graphic tablet and we dive into those parts right now. We will go through this a little bit faster because we do not have to reverse most of the stuff before this. Okay, let's do this. Okay, let's have a look into this one. So this is our beginning of our own code. This one over here. And it goes down till this one. So within this code, we have to verify if we override registers, which has been used over here. Therefore, let's have a look into this one. Okay, so here we can see in this part we set up the v0 register. v0 is initialized with the value 0 over here. Okay, and then let's see. This one it's not relevant. This is our parameter right now. We've got keygen local v0. So now v0 will be assigned to key generator at this point. v0 will be aligned to key generator. Okay, then we've got our try start. v1. v1 is another one. Maybe let's change the color to yellow. So v1 is being assigned to a string, which is AES. Okay, then we've got invoke static on v1 and we move the result into v1. So v1 has been already overwritten at this point and we've got v1 is now our key generator. v1 is now our key generator. Okay, so this v1 is not relevant anymore. And then we move the result from v1 into v0. So at this point, v0 also becomes our key generator. So now also this one. Okay. Then we already knew if we're having two registers with the same object, one of them will be reused. And there we go. Here we've got 100 in hex. So v1 will be overwritten with hex 100. Okay, then we've got invoke virtual. We do not care about this one and it's returning void, so we can move on. Then we've got invoke virtual and now we are returning a different object, this one. So this is our secret key. All right, let's make this a little bit more clear. This is our secret key, our key, and this will be moved into v1. So at this point, v1 will be overwritten with this one. v1 is now holding our key, our secret key. I'm sorry, secret key. Secret key. Okay. So therefore, let's clean this up a little bit. Okay, so this means in this code block over here, in this one, we are not allowed to touch v0 and v1. Let's do it this way. There we go. Okay. Do not override. So then let's have a dip into our code right now. So let's see. All right, we've got invoke interface on v1. Is this correct? v1 needs to be from the type, this one. JavaX crypto secret key. Is v1 at this point secret key? Yes, it is. We've got it over here. So this is perfectly fine. Okay, we've got the method get encoded and we are returning back a byte array. And this byte array will be moved into v2. v2 is fine. v2 is free for use right now. So v2 is good to go. v2 is now our byte array. Okay, this is our key in bytes. Key in bytes. Then let's have a look. So far so good. Then we've got v3. v3 also no problem because we are not allowed to touch v0 and v1. We can of course reuse v1 like we have done it over here, but we are not allowed to override it. So v3, we are now at this line. v3 will be assigned with 0. And this is also perfectly fine. Now we've got invoke static. Okay, we are using the method, or we are calling the method. Let's do it this way. So we are now here and we are calling base64. Base64 encode. Let's see what's the parameter in here. The parameter is, we are having two parameters, and byte array. And byte array, which is v2. And let's change the color. We are also having an integer value, which is v3. Okay, let's see. Byte array v2. Does this fit? Yes. v2 is our byte array. This fits perfectly. And then the integer value is v3. Let's make a comma. And v3 is our integer value 0. So this is also perfectly fine right now. This method works. Okay. Now we have to take care because we are overriding v3. And let's take another color. So v3 is now the base64 encoded string. So the result of this one will be now stored into v3. v3 is equals this one right now. And let's clear this maybe up a little bit. Okay, so we are now at this line. Everything looks good so far. Let's see. Then we've got sGetObject, and now we fetch out our system out. So let's take another color. System out. So we're fetching system.out. System.out. And this one will be stored in, let's see. This will be stored in v4. Okay, v4 is also no problem. It's not v0 and v1. And then let's see. We invoke virtual on our object, so on our field ID. And we invoke print line. So now we are calling system out print line. This is the last line over here in our own code. So let's write this down. We are invoking system.out print line. This returns void. Perfect. And we are having only one parameter, which is from type string. Okay, our string is now v3. v3. Let's verify if this is correct. So let's see. v3 is our base64 encode to string. So this all fits perfectly into our code right now. The reason for this might be because we already start at the beginning of our code and we have copy pasted the first 3 lines over there into this one. And within our own application, we haven't set up anything yet. So this might be the reason why everything looks that perfect. We will encounter things in the next example where this doesn't fit that perfect anymore and we might have to adjust a lot of stuff. But I mean, this one right now, we have verified it and this should work out of the box, which is super amazing, right? Absolutely. Nevertheless, let's check if the transition really works. So over here, we move on with the original code, and this means our register v1 should be still our secret key. This one. Let's see if this is the case. v1 has been used over here. Yes, and it is secret key. So this is perfect. Maybe it's maybe cleaner if we do it this way. So we are not assigning it, we are reusing it. Let's keep it in this way. Okay, and then we only got v0 left, which is not on the screen right now. Let's see. Okay, we have to scroll down then later on and verify if v0 needs to be, what is v0? Our key generator. So maybe v0 is not being used afterwards. This would have meant that we could have used v0 in our code. We have to figure this out, but in case if v0 is not being used, down here, if v0 is not being used anymore, or if v0 is being overwritten. For example, if v0 will be overwritten and it's not a key generator anymore, like this one over here, then we could have also used it in our code. But this is something we have to figure out first. So therefore I would suggest let's simply have a quick look into this one. Okay, so here we are back at the Ubuntu VM. Let's see, v0. Okay, v0 is only used here. Then we've got the beginning of our code, end of our code, and then let's scroll down a little bit. Yes, I cannot see it anymore. So v0 is not going to be used anymore, which is pretty interesting. So it's not being recycled even in the original code. So yeah, this means we could have simply reused v0 in our code over here. So beginning of our code, v0 can be reused. All right. This is it. And therefore I would suggest, let's simply build this application and see if it's working. I mean, this fits perfectly right now, our code, this one over here, into this code over here. And in case it doesn't, we know how to do this right now. So you have to get out your paper sheet and you have to go through this line by line to see if these registers are being initialized or used before, and if you override them. And sometimes you also have some other parameters. And for example, let's say we have a parameter over here, which is v1. Then v1 would be our secret key and it's not an integer value, and therefore we have to adjust it that this parameter would be correct afterwards. All right. Okay, let's revert this. So this has been v3, this is our integer value. So yeah, you have seen how you can do this, and now let's simply build this application and see if we get out our secret key. So let's do this. Okay, ABK tool B, and one challenge to recap all. Oh, it's in here, it's AES. And now let's see. And here we have now this dist. And let's simply verify with JDX GUI what's going on over here. So we are now opening our patched version before we install it and see if everything is correct. AppHacking AES crypto, and there we go. We've got now a system out print line base64 encode to string key get encoded as a parameter, and there we go. So this one is a parameter, it returns back a byte array. This byte array will be transferred into a string, into a base64 encoded string, and this string will be printed out. All of our Smiley line adjustment has been put into one single line over here. Okay? But it looks absolutely perfect. So let's run this. And therefore, we have to zip align it first. Zip align -v AES out APK. And then we have to use the APK signer. And then we have to uninstall the existing version. Oh, the smartphone got disconnected. Yep, that's correct. And there we have it back. Okay, so this is the original version. Then apps, one challenge to recap all, AES dist. We install our version. Oh, it's test only, so -t. And now let's pull out the ADB logcat and let's search for system.out. And let's open this application. So keep this in foreground, and there we go. 3, 2, 1. Nice. Encrypted text. This is regarding to the main activity, I guess. And here we have now our key. This should mean this base64 should change all the time. So we could now take this one. echo-n. base64d. Yes. So here we can get now the bytes. In this way. Here we have now the bytes of our secret key. This is the message. We want to print out the message also, and the initialization vector. This is also something that's missing right now. Let's verify if it might be correct on a first attempt. So therefore, we can leave this open, but we are restarting this application because the key changes all the time. Whoops. So this means we should have now another one. Yes, looks good. Okay. Same size, different value. This looks perfect. The things we are missing so far is the initialization vector, the parameter, and also the return value. But all three of them are byte arrays. So we can take the same approach. In my opinion, this is now a little bit easier to do directly in Smiley because we're having 4 instructions, I guess. 2 to get the base64 encoded string and 2 to print it out via system.out. Of course, you could also do this in the Android Studio, but this video was designed to show you how you can prototype things in the Android Studio to make them work. For example, to play around until we have a method and a way to print out the secret key as a byte array within a base64 encoded format. Figuring this out directly in Smiley is way harder and it's absolutely not required or necessary. So we have a Java environment where we can prototype the stuff, and then if it works, we can simply decode it to get out how it looks like in Smiley. Alright, so if you want to do this, I leave this as a task for you to print out the missing 3 byte arrays. I will do a quick solution in the beginning of the next video, because I would like to finish this video right now. What we have seen is prototyping things in Java is pretty awesome. Decoding it and getting the Smiley code is even more awesome. In this case right now, it wasn't that hard because the transition from the original code into our code back into the original code was pretty smooth. I guess we hadn't have to adjust any register right now. In case if we would have, this is absolutely no problem. We have the skill and knowledge to deal with all of these issues. And we will do this in the next video where we have a little bit a harder task. So there we will have a look into printing out a byte array without a base64 encoded method. Not because a base64 encoded method is not available. It will be always available on the Android system. But let's assume we are having an object and we cannot base64 encode this object. Let's say we have to iterate over this object in the memory and print out every single value. And therefore I would like to show you also the for loop approach. And yeah, this will be a little bit rough. So therefore, I'm looking forward to see you in the last part where we finish this journey over here. So after this one, we are well prepared to perform every task we want to have in Smiley. We could write really complex Smiley code and put this into an own application. So we could do a ton of stuff with Smiley. And this is pretty awesome. So we can circumvent all the security features, print out certain keys, debug information and things like this. And this all without root privileges, because we have directly modified the application. Okay, so this is it for now, and I'm really looking forward to see you in the final video of our challenge over here. So let's go.